Hello everyone, welcome to lesson number 7 for Calculus AB. In this lesson, we're going to talk about derivative rules, more specifically the power rule, the product rule, and the quotient rule. We will do the chain rule in a future lesson, and I also want to say that as we move through this video, all the derivatives we're going to be taking right now are just of polynomials. We just want to get a basis of how to do the power, the product, and the quotient rule. So we're going to start right now with a function that is a constant. So we have the example f of x equals c. So more specifically, let's look at f of x is equal to 3. And we want to take the derivative of this function. Well, if the function is just a constant, then the derivative of all constants is going to be equal to 0. And let me show you why that is. So even though it's really technically not a slope, we have right now equated our derivatives. We're actually making derivatives very similar to a slope, right? So the slope is a rate of change of a line, and the derivative is also a rate of change of a function. So if we're looking at the slope of the line y equals 3, that slope is going to be 0 at all values, right? At all values. So my slope is going to be 0. Any function that's a constant is going to always be a horizontal line, and all horizontal lines have a slope of 0. So from our very first thing right here, we're going to take the fact that if the function is a constant, then the derivative will just simply be 0. So it will just simply go away. So let's talk about the first of 3 major rules that we're going to do. And this is the more straightforward one, the power rule. And so you can see right here that it says if f of x is equal to x, which is our variable, to some exponent, which we're going to call n, then the derivative will be for us to take that exponent and bring it down and multiply by whatever the coefficient is here, leave x alone, and we're going to subtract 1 from its power. So let's actually do a really quick example here before we get into our problems. So if I give you the function and I give you that this is 5x to the third power, and I want the derivative of this. All right, well, right now we have a leading coefficient of 5, we have our variable x, and we have our exponent, which is 3. Well, the power rule is very simple. What's going to happen is we're going to move the 5 down, and we're going to multiply it. We're going to multiply it times the leading coefficient. And if this has just been 1, then it'd be 3 times 1, which is 3. But in this case here, we have 3 times 5, which is going to give us 15. And then we're going to go ahead and do x, and then all we're going to do is subtract 1 from the exponent. And that, ladies and gentlemen, is the actual power rule. It's not very challenging. And then the other thing that we can see here is that if we have a constant in front of the function, we can just leave the function alone. This goes back into the product rule that we'll get to a little bit later on. And then the sum and difference rule is just basically saying, and I'm going to use that down here in example 1, where it says find the derivative of this whole polynomial. The sum and difference rule basically means that I can find the derivative of this independently of this, and these terms, but I can put them together. So that's really all this says, is that I can take the derivative of functions, pieces of the functions, and then just add them back up. So let's actually do some examples and just make sure that we're good with what we have to do here. So for example number 1, it says find the derivative of this polynomial. And so I'm going to go ahead and notice the notation. So I've changed my f of x to f prime of x. That represents that we have a derivative. You guys have already seen other forms of derivatives, y prime. That's one. And the one we're going to talk about quite a bit in this class will be the change in y with respect to x. And that's important for later on when we talk about implicit. So right now we're taking the derivative of these functions. So what the sum and difference rule basically means is that I can go ahead and just take this derivative independently. So I'm going to move the 6 down and multiply by 5. So I'm going to get 30. I'm going to go ahead and write the x, and I'm subtracting 1 from the power. So I'm going to get 5. And then I can go and move to the next part and find the derivative of this. Well, the derivative of negative 3x to the fourth, well, I move the 4 down and multiply it by negative 3, and I get negative 12. I get x, and then again, I subtract 1 power. And ladies and gentlemen, it's just that simple. So now we've done 2. We got 3 more to do. I'm going to move 3 down. I'm going to multiply 3 times 2. I'm going to get 6. We're going to do x to the 1 less power. I'm going to go ahead and move the 2 down and multiply it by negative 8. I'm going to get negative 16. X to the 1 less power, which is 1. And then again, the derivative of a constant is 0. If you guys want to see another way of doing that, this is really x to the 0 power, right? X to the 0 power is just 1. If I move the 0 down, I multiply 0 times 17, and I get 0. So this is our derivative for our polynomial using the power rule. So it's straightforward, very awesome power rule question. Okay? So let's look at example number 2. So first of all, looking at example number 1, notice that the question was asking us to find the derivative of. Well, this is saying find the slope of the tangent line. And again, we're actually saying that these are the same thing. So the slope of the tangent line is just actually finding the derivative. Now it's actually asking us to evaluate this at x equals 1. So what we're actually looking for in this problem is we want to find the derivative of our function, and we want to find out where it is evaluated at 1. So this is what we're looking for, right? So the derivative as x approaches 1 of our function. Well, let's first of all figure out what f of x is. Well, we're going to use, yet again, the power rule, right? So we're going to move the 4 down and multiply it by 3, which is going to give us 12. We're going to do x to the 1 less power, which is going to be 3. And now this is going to be understood as a 1, right? So we have now one where we have, and so this is another really good one to actually put in our little lesson here. So we have some number cx, right? Some number cx. So let's talk about what this derivative is. So I can move the 1 down, and it's going to be negative 5 times 1, which is going to be negative 5, and it's going to be x to the 1 less power, which is going to be 0. Right, so we all know that this, and then again, the derivative of a constant is just going to be 0, right? So this is going to be plus 0 because this becomes 0. So we simplify this, we get 12x cubed minus 5x to the 0 power is just 1. So this is going to be our derivative, and I should have put my notation right there for it. So this is going to be our derivative. And now, ladies and gentlemen, all we want to do is plug in 1 to this function. So we're going to get 12 times 1 cubed minus 5, which is going to be 12 minus 5, which is going to give us 7. So the slope of the tangent line of our function at x equals 1 is going to be equal to 7. So back up here to another rule that we can use is that if we have a function where we have just a number times x, then the derivative is just always going to be that number, right? It's always going to be that number. So here's another little rule that we can have in our little information. Can't think of the word that I'm trying to say there. So we'll just say if there's another thing we need to know, right? So yeah. So let's go ahead and move on to our third example. And I'm keeping all 3 examples on the page for 1 second because I want to just say something. So this one, it said find the derivative. We literally found the derivative. Question number 2 said find the slope of the tangent line. We also found the derivative. Well, the third one says find the instantaneous rate of change of the function. Again, we're finding, you guessed it, the derivative. We're going to find the derivative of this function. So these are 3 ways of asking the same kind of type of question where we do the same method. So we look at this question, the instantaneous rate of change, which again, we will abbreviate quite a bit as IROC. So this is find the instantaneous rate of change of the function where x is equal to -1. So that's exactly what we're going to do. We're looking for f prime of -1. That's what we want to look for. That's what we want, right? So derivative, slope of the tangent line, instantaneous rate of change, they all are asking us simply to find the derivative of the function. So let's go over here and find out what our derivative is. So don't let the fractions scare us. We move the 4 down. We have 4 over 2. Right, we have 4 over 2x to the third. Yes, I will simplify that in a minute. So 4 over 2x cubed, and then I'm going to move this down. I'm going to have 3, and remember it's going to be 3 times 2/5. So 3 times 2/5 is going to be just 6/5 x squared. And then we've actually already talked about this derivative, right? So this is just a constant times x, just like we said right here. So the derivative of 2x is just going to simply be 2. And again, we have a constant of -3, and -3 would just end up being 0. So there is our derivative. Let's simplify this down a little bit more than we can. And the only way we really need to do that is just make it a 2. So 2x cubed plus 6 over 5x squared plus 2. And now it's asking us to find the instantaneous rate of change when x is equal to -1. So now we're going to figure out, well, what is f prime of -1? Well, we're going to do 2, and then -1 cubed is going to be -1. So we're going to do -1 times 2 is going to be -2. -1 squared is just +1. So +1 times -6/5 is going to be -6/5. And then we're going to do our +2 here. And normally, if this did not awesomely cancel out, right, -2 and 2, they cancel out. So our answer is simply going to be -6/5, which is amazing that we don't have to do too much more with this. By the way, if it's an FRQ, free response question, you leave it like this, ladies and gentlemen. Don't simplify, don't simplify. And you can actually left it 4 over 2 for all I care. But for the purposes of multiple choice questions, it's most likely going to be this. Yeah, so it's okay if it's -6 over 5. -1.2 is also good, but we like to keep it in fraction form. But again, if this had not been -2 and 2, then I would have put everything as a common denominator and just found out that way, okay, without the calculator use. Okay, so then the question number 4 says find the equation of the tangent line. All right, so the equation of the line tangent to the curve. So the fact that we see tangent, so this word tangent right here basically means we got to find the derivative. All right, so the equation of the tangent line means we got to first of all find the slope of the tangent line. So find the slope of the tangent line, the slope of the tangent line, right? The slope of the tangent line is going to give us our derivative. We want to figure out what f prime of 1 is. So let's do that very quickly. So we're going to do f prime of x, and that's going to give us 6x minus 4. So a pretty nice little function for us here. And so f prime of 1 is going to give us 6 times 1 minus 4, which is going to give us 2. So we want to make a note here that we want to do it in point slope. And that's how we want to leave our answers. We don't want to go into standard form or slope-intercept form. Point slopes is completely fine. So in calculus, what I'm going to end up doing a lot of times is I'm going to actually change this slope here to the actual derivative. Okay, and in this case here, this is also equal to dy dx. So we found this. So if we look at our problem and we do our problem here, then we know that this is going to be 2. We also know that x, our point, is going to be 1, right? Because x equals 1, so it's going to be x minus 1 here. And so how do we find our y value? Well, if I gave you guys algebra 1 time, if I gave you f of x, and I said x equals 1, what's the corresponding y value? Well, then just find what f of 1 is. So this y value is actually just going to be f of x. Okay, f of x is just going to be f of 1. So we're going to plug into our original problem. We're going to get 3 minus 4 plus 5, and then we're going to get that this is going to be 4. Right, this is going to be 4, so it's going to be y minus 4. So this is the equation of our tangent line to our curve at x equals 1. So let me rewrite, actually, so we can kind of have this as our little guide. Let me rewrite on my paper for us how to rewrite this equation using calculus. So it just be y minus f of x is equal to f prime of x times x minus x1, all right, or whatever, this x value is right there. So this is going to be our function for what we do. And when we talk about linear approximation a little bit later on in the course, then this will make a lot more sense of how we do that. Okay, so that is the power rule and a lot of really good ways of actually explaining it to you guys. So let's continue on with the power rule for one more time and let's talk about negative exponents and exponents that are fractions. So ladies and gentlemen, I got 2 more examples for you here for the power rule, and it's just where we have negative exponents or x to a fraction. And it's the same rule as before. It's exactly what you do. There's nothing changing about it. We just got to be kind of careful about what we do with our signs. So let's go ahead and find the derivative of our function 3x squared minus 4x plus 5x to the negative 1. And I will tell you guys, and I know that we all know this, so I'm not trying to insult anyone's intelligence with this problem, but I know that if you see your function like so, right, then you could just move this up to be x to the negative 1. So, sometimes you'll see it like that. So just like before, we're going to move the 2 down and multiply it by 3. So this is going to give us 6x to the first, right, which is just really 6x. Again, ladies and gentlemen, we have a negative constant times x, so that derivative is just going to be the constant, so just negative 4. And then we're going to do the same thing here. We're going to do the same thing here. We're going to move the negative 1 down, and we're going to multiply it by 5. So this is going to be a negative 5x, and you just want to be very careful. We still want to subtract 1 from our exponent, so negative 1 minus negative 1 is actually negative 2. So that is going to be our derivative. So we would just rewrite this, and you don't have to simplify, but calculus, we're not a big fan of negative exponents for the most part. So we do want to make sure that we write it down as, that's supposed to be a 5, by the way, this function right here. So here is our derivative to our function. So same old story. You move it down, move the exponent down, you move it, multiply by the leading coefficient, you take x, you subtract 1, and then simplify your exponent. So easy, 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 pretty sweet. All right, so for this one, our last example for this video, we're going to do 4, and we're going to do x to the 1/2 power, right? And so here's our function as we've written it down right here for us. And so let's go ahead and knock this thing out. And notice again, it also says find the equation of the line to the curve, right, when x equals 4. All right, so this says find the equation of the line to the curve. Usually tangent is inferred here, so we would actually use the tangent line. So I would write the tangent line for you guys. So f prime of x, I moved the 2 down and multiply times 3, so I'm going to get 6x, right? We just did that derivative right there. And so the same thing here. It's going to be -4. I'm going to move the 1/2 down, and I'm going to multiply 1/2 times -4. So that's just going to give me -2, right? Or just 4 divided by 2. It's going to be x to the 1 less power. So it's going to be 1/2 minus 1, which is going to be 1/2 minus 2/2, which is going to give me a -1/2 power. And the derivative of our constant is actually just 0. So our derivative, f prime of x, is going to be equal to 6x minus 2 over the square root of x, right? And again, I know this is not trying to solve anyone's intelligence, but remember this negative exponent is just on the x and not on the 2, so leave the 2 alone. So let's actually find the answer to our problem here, right? So we found our derivative, which is good, but we want to know when x is equal to 4. So we want to find out when our derivative is 4. So go ahead and plug in 4 like we normally do. So we're going to go ahead and get 24 on the first part. And we're going to get 2 over, and remember this is the square root of 4. The square root of 4 is just going to be 2. So this is going to give us 23. So our derivative part of our formula is going to be equal to 23. And then how we find the other part, what we do to find our y, right? Because we need a point and a slope. That's always when I taught Algebra 1. I always said you guys always need a point and a slope. Right, so here's our slope, and now we got to find our point. So plugging back in, going back to f of 4 in our case, we're going to take 4, we're going to square it, we're going to get 16. 16 times 3 is going to be 48. We're going to do 4 times the square root of 4, which is 2, minus 4. So we're going to get 48 minus 8 minus 4, and that's going to give us 36. So that's going to give us the point 436. And so our final answer for this problem and for this video is going to be y minus 36 is equal to 23 times x minus 4. And there you go. There is a very easy way of finding the equation of the tangent line to this curve at x equals 4. All right, so I'll leave you guys there with the power rule. I hope that you guys thought this was probably one of the easier videos to understand. And the next one we're going to talk about is our friend, the product rule. So I'll see you guys back in the next video. Take care.